I'm going to talk about static equilibrium and how to solve questions like what we have now. So in this question, it says that we have an object with a 30 kilogram in a static equilibrium that supports by two cables that makes an angle of 60 with x-axis as shown in the figure on the left. What is the tension on each cable? So we need to find A and B. We can also name the tension cable T1 and T2 to find them. So it would be very easy. So let's start. So first of all, we should draw a line with a cable sorry, the cables are coming like that. Okay, and here we have a 30 kilogram as shown in the figure. 30 kg. Okay, so we will name this one by T1, or let's say to T2, and this is T1. Okay, so let's start. And there is also, wait, we have 60 degrees there. I should draw it. Okay, so we have 60 degrees from both sides with a 30 kilograms. Okay, so as you can see here that it's tension, and we have we have a F net on the x-axis, net equal F net x equal to 0, and F net y equal to 0, because the object is not moving. Okay, so now we should get the equation of F net x equal to 0 and the F net y equal to 0. First of all, we should label the T1x and T2x and T2y and T1y and mg. So mg, it's the same as weight. It goes down, direct to down. M G. And here we will have we will have the y-axis on the t, and we will have the y-axis on t1. Okay, and now we will label them as, here it will be T1 Y and T1 X. And here it will be T2 Y T2 X. Okay, so now we should start to find all of these: mg, t1x, t1y, t1, t2x, t2y, and t2, t1. So to find t1 and t2, we should find these 5. So we will start with mg. Okay, let's start with mg. The mg equal to mass times the gravity. The mass times the gravity, and the answer will be 294. I think let's calculate it on calculator. Yes, it's 294 newtons. I can just write it there as 294. Newtons. Okay, and now we will try to find T1x. T1x. I think with the keyboard it will be faster. T1x equal to, okay, so you can see that T1x, it's here, and with this degree the T1 is adjacent to the degree here, so we will use cosine because the T1x is adjacent to 60 degrees, and to write it we should write like what I should write, like that, cosine 60 degree equal to, no, not equal, multiplied by T1. That's very easy. If you asked why you multiply it with T1, there is a very fast explanation for this. For you to not confuse, you should learn these triangles. The first triangle, I will draw it here. This triangle will be for the sine. Sine will be down and the opposite be up and hypotenuse will be down. It's because of SOHCAHTOA. SOHCAHTOA. Always remember that the angle that's in the middle will be up, like the opposite in sine. And also for cosine, you will have it as the following. Cosine adjacent and hypotenuse. Also for the tangent, you will have a tangent here and opposite up with an adjacent down. And as you know, the triangle sine multiplied with hypotenuse will give you the opposite, and hypotenuse will be equal to opposite divided by sine, and it will be the same with these all triangles. The two down will multiply by each other to get the opposite here up, and to get one of these two we should divide the opposite on one of these. Like if such for example, if we want the sine, we should divide opposite to hypotenuse, and if we want hypotenuse, we should divide opposite on sine, and if we want opposite, we should multiply sine by hypotenuse. Okay, so let's continue and find. Now we will find T1y. So to find T1x, the adjacent in the cosine, we should multiply cosine and hypotenuse. This one, the T1 and the 60 degrees cosine. And you will see here, wait a minute, with the T1y equal. Okay, so as you can see that T1y is opposite to the 60 degrees. So here we will use sine to get the T1. And wait, I will write it for you. 60 degrees multiplied by t1. Also again, to show that sign here, and to get the hypotenuse we should, no, to get the opposite t1y, this one, we should multiply these two to get t1y as shown here. To get the opposite we should multiply sine with hypotenuse. Let's continue. Now we will find t2x, and t2x is equal to, let's check, adjacent, so we will use cosine, and it will be with us 60 degrees as shown, multiplied by t2, multiplied by t2, and for t2y it's equal to sine 60 degrees multiplied by t2. That's very easy to find all the sides as shown here. So let's write the equation of the f net x, which is t1 x minus t2 x is equal to 0. And for the y-axis it's t2y plus t1y minus mg equal to 0. Okay, first question, why the t2 is minus, wait, like that, why the t2 is minus? That's because because of t2 is pointing on the left side and t1 is going to the right side, so t1 will be positive and t2 will be negative as shown here. And also for the y-axis, both t1y and t2y are pointing upward, so they will be positive, and mg will be negative because it points downward. So now we will substitute these numbers here. So let's check. Okay, now we would solve, wait for the f net x. Okay, so first of all we should substitute these numbers inside this equation. t1 x is the cosine of 60 degrees multiplied by t1 and minus the t2x cosine 60 degrees multiplied by t2 equal to 0. So that's very easy. First of all, the first step we will shift this to the other side, so it will change the sign. We should plus both sides by cosine of 60 okay. So now we will have a cosine 60 multiplied with a t1 equal to the cosine 60 multiplied by t2. Okay, so to get the t1, we should substitute I should divide this cosine 60 to this one, to this all. So like that, we will have a cosine of 60 degrees divided here and here. So these two will cancel, and also these two will cancel. So the answer will be T1 equal to T2. That's the final answer. T1 equal to T2. That's for f net x. So now we should substitute there in the equation of the f net y, the T2y and the T1y mg. So let's start here with f net y with the mg, no, with the T2y, sine of 60 multiplied by T2. This is T2y plus T1y minus plus the T1y, so it's a sine of 60 multiplied by T1 minus the mg, which is 294, equal to 0. Okay, and for this one we could just use shift solve to get it, but before that we have answered that we have said that T1 is equal to T2, so we should substitute here the T1 with the T2. So we will write sine the 60 degrees multiplied by T2 plus a sine of 60 multiplied by T2 minus T294 equals 0. And now we can use the shift solve on the calculator. Sine 60 plus sine 60. Okay, so the answer is very easy, just 169.7 as shown on the calculator in the shift solve here. Just a second. And you should put your calculator on degree, not on radian. On radian it will be wrong answer. Yes, so I had here this 2 T2 is equal to 169.7 newtons. And so as we say before that T1 is equal to T2, so T1 also will be equal to 169.7. So that's all. That's a very easy question.